Tron, I've heard that you're interested in math puzzles, and this is one that I wanted to give to you. So it's about trying to figure out in tic-tac-toe whether it's always possible to win. So here's the tic-tac-toe board, and what I want you to think about is X goes first, right? So how many different ways could X go on their first move? So one possibility is that X would go in this upper left corner, right? But then there's another possibility X could go here, and there's a third possibility, which is that the first move that player X makes is in the center. Now, if you think about it, there really aren't any more different possibilities, because if you tried to play in this corner, for example, that would be the same as just turning the board around. And when you turn the board around, you would just be like passing the tic-tac-toe piece of paper to the other person, and it's really the same game, right? So there's the center square, there's the squares that are in the middle of a side, and there's the corner squares, right? There's 4 ways to do corner squares, 4 ways to do this one, and only 1 way to play in the center. But these, when the game starts, are the only possibilities if you let yourself move the board. So now the next player is, player O, right? And we're going to think about where they can go next. Now, let me draw the board here. So it's possible, right? I'm going to draw a couple different cases. Okay, so now where does, if the first player is played in the middle, then where can player O play? Well, player O can play in a corner square, or player O can play in one of the middle of the side squares. But actually, there's no other move, right? Because any other move would be the same. Any other move would be the same if you just rotated the board. So like if player O played here instead, well, that's the same as this one, turning the board. Okay, so now what I'm going to do is I'm going to connect this board and this board, right? So this is the first move up here that player X makes, and this is the second move which player O makes if the first player played in the center. And now we're going to do this next one. What if the first player plays in the middle of the sides? So I know there'll be at least 2 different ones. So if the first player played up here, then the second player could put their O here in this corner. The second player could put their O here, right? And if the first player was in the middle here, is there another place where the second player could go? Player O could go in the center. Player O could go here. If the first player played here, the player O could go here. And if the first player went here, player O could go here. But look at this one. With X going first and O going here. Nope, that I was going to say it was the same as one of the other ones, but it isn't. Okay, so if I counted them all right, if you're in this move, there's these different ways that you can go next. Okay. Now, there's going to be ways that you can move from here, right? And when you're in each one of these games, there's going to be ways that you can go where the next player can move. And the problem, or the math problem, is to draw this entire tree of possibilities for the tic-tac-toe game and then decide what is the best way that you should start the game if you're player X. And if you're player O, what should you do depending on what player X does? So the question is, can you always win at tic-tac-toe if you make the best move? Or can you only sometimes win? Is it always possible if you're the second player to make a tie? Or is it possible that the first player can outplay you even if you're playing your best? And you can figure all that out if you draw all these possibilities. Now you might think that there's so many possibilities when you do this for several steps that this is impossible. But it's only about 50 different tic-tac-toe boards that you have to draw. And because remember, for example, if you got to the tic-tac-toe board that looked like this one, as the board starts to fill up, maybe we have an X, an O, an X, and an O, right? Well, it doesn't matter what order those were played. So this board and then the three other boards that you get by turning this around, right, are really the same. And as you go down through this tree, you might end up being able to get to this board in multiple ways, right? So, let's see, I've got X here, O, and O, and the question is, this board will be able to get here eventually, right? And this board will be able to get to this state eventually. So these aren't really right. So my point is that it's not as many boards as you might expect, because as you continue to make this sort of branching thing here, it'll start to come together, and there's only a certain number of ways that the game can finish. So remember, when somebody gets to a tic-tac-toe, you stop, right? Because that's when the game ends and you know who the winner is. So this is a challenge. It's like 50 or 60 different little tic-tac-toe boards all connected by these lines. But if you look at it when you're all done on a big piece of paper, you can actually understand the game of tic-tac-toe, and you'll never lose again. I recommend what you do is you make the individual tic-tac-toe boards on a card and then tape those cards onto a bigger piece of cardboard or something like that, so that you can move them around if you figure out that you kind of need more space in one place or the other. So I don't know if you think that's going to be fun or not, but it's something that I did when I was your age, and I was sort of surprised at the answer.